JUnit 4.12 in JUnit. Now you can see here the test runner for running test in JUnit 4. JUnit is a simple open source unit testing framework tool to write and run repeatable unit tests. Also, it is an instance of the XUnit architecture for unit testing framework. It is mostly used as the unit testing tool by most developers. The main features are as below. The annotations to mark the method as the test methods, assertions for testing expected results and actual results. The test runner for running test are as shown below this picture. Here the code repository is connected to source code and unit tests. Here the source code is connected to test runner and unit test is connected to test runner. Invoke test is are connected to test runner, and test runner is connected to reports. Here you can see the different the JUnit 5 versus JUnit 4. Here the before hole instead of before class, and at after all instead of at after class, and at before each instead of at before, and at after each instead of at after, at disable instead of at ignore, at tag instead of at category, assert throws instead of expected attribute, assert timeout instead of timeout attribute. Here the annotation type before class. Sometimes several tests need to share computationally expensive setup like logging into a database. While this can compromise the independence of test, sometimes it is a necessary optimization. Annotating a public static void no arg method with at before class causes it to be run once before any of the test method in the class. The at before class methods of super classes will be run before those of the current class unless they are shadowed in the current class. Annotation type after class. If you allocate expensive internal resources in a before class method, you need to release them after all the tests in the class have run. Annotating a public static void method with an at after class causes that method to be run after all tests in the class have been run. All after class methods are guaranteed to run even if a before class method throws an exception. The after class methods declared in superclasses will be run after those of the current class unless they are shadowed in the current class. Annotation type before. When writing test, it's common to find several tests need similar objects created before they can run. Annotating a public void method with at before causes that method to run before the test method. The at before methods of superclasses will be run before those of the current class unless they are overwritten in the current class. No other ordering is defined. If you annotation type after in org.JUnit, if you allocate external resources in a before method, you need to release them after the test runs. Annotating a public void method with at after classes causes that method to be run after the test method. All at after methods are guaranteed to run even if a before or test method throws an exception. At after methods declared in a superclass will be run after those of the current class unless they are overridden in the current class. Annotation type ignore. Sometimes you want to temporarily disable the test or group of tests. Method annotated with tests that are also annotated with at ignore will not be executed as tests. Also, you can annotate class containing test method with at ignore and none of the containing test will be executed. Native JUnit for test runners should report the number of ignored tests along with the number of tests that ran the number of tests that failed. Annotation type category marks a test class or test method as belonging to one or more categories of test. The value of an array value is an array of arbitrary classes. This annotation is only interpreted by categories runner at present. Here you can see the annotations in JUnit 4. There are two main abstract model for JUnit framework. One of it is the abstract of test unit. Each test unit has its own scope, name, initial state, and the way how to release the resources which are allocated during the testing time. The JUnit 4 it uses inheritance models to represent that concept. With the annotation, the framework use reflection to get the meta information of the test unit. The class has its own member, so JUnit use abstract method abstract class framework member to represent it. The class member can be classified into a field and method. JUnit uses framework field and framework method which inherit from framework member. Framework field maintain a private object of class field which is used in reflection. So do framework method. Here the can see the interface annotatable in dog.junit.runners.model, a model element that may have annotations. Here the framework, the class framework member type parameter t, extend framework member type parameter t. Here the class framework method represent a method on a test class to be invoked at the appropriate point in test execution. These methods are usually marked with an annotation such as at test, at before, at after, at before class, at after class, etc. Here class framework method in org.JUnit.runners.model represent a method that on a test class to be invoked at appropriate point in test execution. These methods are usually marked with an annotation such as at test, at before, at after, at before class, at after class, etc. Class test class wrap a class to be run, providing method validation, annotation, searching. Here you can see the interface annotatable. The implementing classes are framework member, test class, and there are other two implementation class, test class, and here the framework the framework class framework framework member. Here the direct known subclasses, framework method and framework field. Here you can see an important inheritance in JUnit 4. JUnit tests I started using JUnit core class. It will can run us to finish the tasks. Other important inheritance shown here. The public class all default possibilities builder, extend, runner builder will be called and try to find runners to run test classes which are written by user. Finally, block JUnit 4 class runner will be called. Here you can see the interface filterable in org.JUnit manipulation. The runners that allow filtering should implement this interface. Implement filter to remove tests that don't pass the filter. The interface describable in org.JUnit.runner represent an object that can describe itself. The interface sortable in org.JUnit.runner.manipulation. Interface for runners that allow sorting of tests. By sorting tests based on when they last failed, most recently failed first, you can reduce the average time to the first test failing. Test sorting should not be used to cope with the order dependencies between tests. Tests that are isolated from each other are less expensive to maintain and can be run individually. Class runner. A runner runs test and notifies a run notifier of significant event. As it does so, you will need to subclass runner when using run with to invoke a custom runner. When creating a custom runner, in addition to implementing the abstract method here, you must provide the constructor that takes an argument the class contained in the test. The class parent runner type parameter t provides most of the functionality specific to the runner that implements the parent node in the test tree with children defined by object of same data type t. For block JUnit for class runner, t is method, and for suit t is class. Subclasses must implement finding the children of the node, describing each child and running each child. Parent runner will filter and sort children, handle at before class, at after class method, handle annotated class rules, create composite description, and run children sequentially. The class block JUnit for class runner in org.junit.runners implements the JUnit for standard test case class model as defined by the annotations in the org.junit package. Many users will never notice this class. It is now the default test class runner, but it should have exactly the same behavior as the old test runner, JUnit for class runner. The class JUnit 4 aliases the current default JUnit 4 class runner. For future proofing, the future versions of JUnit change the default runner class. They will also change the definition of this class. Developers wanting to explicitly tag a class as a JUnit 4 class should run with JUnit 4.class, not for example in JUnit 4.5. The class block JUnit 4 class runner with parameters in org.junit.runners.parameterize. A block class for class runner with parameters support. Parameters can be injected via constructor or an annotated fields. The class suit in org.junit.runners. Using suit as a runner allows you to manually build a suit containing tests from many classes. It is the JUnit 4 equivalent of the JUnit 3.8.x static test suit method. To use it, annotate the class with @run with suit.class and @suit classes test class 1.class etc. Then you run this class, it will run all the tests in all the suit cases. Class parameterize in org.junit.runners. The custom runner parameterize implements parameterized tests. When running parameterized test class, instances are created for each cross product of the test method and the test data elements. Here the Parent runner implemented the interface, the implemented interfaces are here filterable and sortable. And the superclass is runner, and runner implements desirable interface. Parent runner has subclasses block, JUnit 4 class runner, and suit. Block JUnit 4 class runner has subclasses JUnit 4 and block JUnit 4 class runner with parameters, and suit has subclass parameterize. Here you can see the life cycle of JUnit 4. Here the before class, an annotated public static void no argument method will be executed before execution of any test method in the class. At after class, an annotated public static void no argument method will be executed after all test methods of this class are executed. At before, this method will be called before each test method in the class. At after, this method will be called after each test method in the class. The annotation type before class. Sometimes several tests need to share computationally expensive setup like logging into database. While this can compromise the independence of tests, sometimes it is necessary optimization. Annotating a public static void no arg method with at before class causes it to be run once before any test method in the class. The at before class method of superclasses will be run before those of the current class unless they are shadowed in the current class. Annotation type before. When writing tests, it is common to find that several tests need similar objects created before they can run. Annotating a public void method with the before at before causes that method to run before the test method. The at before method of superclasses will be run before those of the current class. Unless they are overridden in the current class, no other ordering is defined. The annotation type test. The test annotation tells JUnit that the public void method to which it is attached can be run as a test case. To run the method, JUnit first constructs a fresh instance of the test class, then invokes the annotated method. Any exceptions thrown by the test will be reported by JUnit as a failure. If no exceptions are thrown, the test is assumed to have been succeeded. Have succeeded. The annotation type after. If you allocate external resources in a before method, you need to release them after the test runs. Annotating a public void method with after causes that method to be run after test method. At after method are guaranteed to run even if at before or test method throws an exception. At after methods declared in superclasses will be run after those of the current class unless they are overridden in the current class. Annotation type after class. If you allocate expensive external resources in a before class method, you need to release them after all tests in the class have run. Annotating a public static void method with at after causes that method to be run after all the tests in the class have been run. All after class methods are guaranteed to run even if a before class method throws an exception. The at after class method declared in superclasses will be run after those of the current class unless they are shadowed in the current class. Here you can see the test class lifecycle. Start is connected to at before class. At before class is connected to here the for each and here for each at test case. Here you can see the at before and then at test, and after that then at after. Then it's connected to at after class and then end. Now we are focusing on JUnit 4.12. As an example, we can consider this code segment. Here the annotation type test. The test annotation tells JUnit that the public void method to which it is attached can be run as a test case. To run the method, JUnit first construct a fresh instance of the class when then invokes the annotated method. Any exceptions thrown by the test will be reported by JUnit as a failure. If no exceptions are thrown, the test is assumed to have succeeded. This is in the package package org.junit. As an example 2, we can consider this Maven segment. Maven Surefire and Maven Failsafe can run JUnit 4 based test alongside Jupyter tests as long as you configure test scope dependencies on JUnit 4 and the JUnit vintage test engine implementation similar to following here. And you can see here JUnit 4 and the scope test. Now we are considering here the annotation interface type enable JUnit for migration support in package org.junit.jupyter.migration support in modules org.junit.jupyter.migration support. Enable JUnit for migration support is a class level annotation that enables all JUnit for migration support within JUnit Jupyter. I included this here basically for the annotation, but this is in the JUnit org.junit.jupyter. Now we are considering category support in running JUnit 4 test on the JUnit platform in migrating from JUnit 4. For test classes or methods that are annotated with at category, the JUnit vintage test engine exposes the category fully qualified class name as a tag for the corresponding test class or test method. For example, if a test method is annotated with, like here, the at category here example.class, it will be tagged with here com.seme.example Similar to the categories runner in JUnit 4, this information can be used to filter the discovered test before executing them. Now we are considering migration tips. The following are the topics that you should be aware of when migrating existing JUnit 4 test to JUnit Jupyter. Annotations reside in the org.junit.jupyter.api package. Assertions reside in org.junit.jupyter.api.assertions. Note that you may continue to use the assertion method from org.junit.assert or any other assertions library such as assert j, hamcrest, truth, etc. Assumptions reside in org.junit.jupyter.api.assumptions. Note that the Jupyter 4.5.4 and other versions support method from JUnit's 4's org.junit.assume class for assumptions. Specifically, JUnit Jupyter supports JUnit 4's assumption violated exception to signal that the test should be aborted instead of marked as failure. At before and at after no longer exist, used at before each, at after each instead. At before class and at after class no longer exist, used at before all and at after all instead. Ignore no longer exist, used at disabled or one of the other built-in execution condition instead. At category no longer exist, use at tag instead. At run with no longer exist, superseded by at extend with. At rule and at class rule no longer exist, superseded by at extend with and at register extension. At test expected equal etc. And the expected exception rule no longer exist. Use assertions dot assert throws instead. Assertions and assumptions in JUnit Jupyter accept the failure message as their last argument instead of the first one. Now we are considering JUnit for rule support. This limited form of rule support can be switched on by the class level annotation at enable rule migration support. The annotation interface at enable rule migration support in package org.junit.jupyter.migration support.rules in module org.junit.jupyter.migration support rules. This annotation is in Jupyter. As stated before, the JUnit Jupyter does not and will not support JUnit 4 rules natively. The JUnit team realizes, however, that many organizations, especially large ones, are like to have large JUnit 4 codes bases that makes use of custom rules. To serve these organizations and enable a gradual migration path, the JUnit team has decided to support the selection of JUnit 4 rules verbatim within JUnit Jupyter. The support is based on adapter and is adapters and is limited to those rules that are semantically compatible to JUnit Jupyter extension model. That is, those do not have completely changed the overall execution flow of the test. The JUnit Jupyter migration support module from the JUnit Jupyter currently supports the following 3 rule types, including subclasses of these types. org.junit.rules.external resource, including org.junit.rules.temporary folder. org.junit.rules.verify, including org.junit.rules.error collector, org.junit.rules.expected exception. As in JUnit 4, rule annotated fields as well as methods are supported. By using these class level extensions on the test class, such rule implementation in legacy code bases can be left unchanged, including JUnit 4 rule import statement. This limited form of rule support can be switched on by the class level annotation at enable rule migration support. This annotation is composed annotation which enable all rule migration support extensions, verifier support, external resource support, and expected exception support. You may alternatively choose to annotate your test class with at enable JUnit migration, JUnit 4 migration support, which registers migration support for rules, and JUnit 4's at IGNO annotation. However, if you intend to develop a new extension for JUnit Jupyter, please use the new extension model of JUnit Jupyter instead of rule-based model of JUnit 4. Now we are considering JUnit 4 at IGNO support. The IGNO condition is an execution condition that disables test classes or test method that are annotated with at IGNO. In order to provide a smooth migration path from JUnit 4 to JUnit Jupyter, the JUnit Jupyter migration support module provides support for JUnit 4's at IGNO annotation, analogous to Jupyter's at disable annotation. To use at IGNO with JUnit Jupyter based test, configure the test dependency on the JUnit Jupyter migration support module in your build, and then annotate your class with extend with IGNO condition class. So enable JUnit 4 migration support, which automatically registers the IGNO condition along with limited JUnit 4 rule support. The IGNO condition is an execution condition that disables the test classes or test method that are annotated with at IGNO. Now we are considering failure message argument. The method affected by this change are as follows. The assumptions and assertions classes in JUnit Jupyter declare argument in a different order than in JUnit 4. In JUnit 4, assertion and assumption method accept the failure message as first argument, whereas in JUnit Jupyter, assertion and assumption method accept the failure message as the last argument. For instance, the method assert equals in JUnit 4 declared as assert equals string message object expected object actual, but in JUnit Jupyter is declared as assert equal object expected object actual string message. The rationale for this is that failure message is optional, and optional argument should be declared after required arguments in the method signature. The method affected by this change are the following: assertions, assert true, assert false, assert null, assert not null, assert equals, assert not equals, assert array equal, assert same, assert not same, assert throws. Assumption: assume true, assume false. Test annotation supports two optional parameters for exception testing and for limiting test execution time. Here we are considering expected parameter for as an exception example here. The parameter expected declares that the test method should throw an exception. If it does not throw an exception, or if it throws a different exception than the one declared, the test fails. For example, this test succeeds here. Using the parameter expected for exception testing comes with some limitations. Only the exceptions type can be checked, and it is not possible to precisely specify the code that throws the exception. Therefore, JUnit 4 has improved its support for exception testing with assert throws class throwing runnable and the expected exception rule. With assert throws, the code that throws the exception can be precisely specified. If the exception's message or one of its properties should be verified, the expected exception rule can be used. As an error example, we can consider this one occurred in Android Studio. Failed to resolve JUnit 4.12.